Okay, I just want to go over the spreadsheet for week 9 and explain what some of these numbers meant to clarify. So first of all, we had the movies, and we got a histogram of each one of the year and of the length. Your original one with length should have had a movie way out to the right, 900 minutes or something like that, Berlin Alexanderplatz. And that's really a series, which is why it didn't fit in here. So once you delete that, you should get something that looks like this. The point I made about Psycho, making sure you classify that correctly, was that it was the 50th movie, but because you had your headers in row 1, it would actually come in on row 51 or 52 in the case of this student, because she had put another row up here for old. So Psycho should be in there with the old movies. To explain the output here, we have the mean of the two groups. So this is the average movie length for the 50 older movies and the average movie length for the 50 newer ones. And I think most of you got that. Here was the variance for each variable. Observations, this would let you know how many data points there were actually. In your older movies, there should have been 50 of them and 49 in the newer ones. If you had copied my output, I was actually testing something else related, but I only had 13 movies in each sample, so that would not give you this 50 and 49. This pooled variance is what you should have used later on, not these two. There's a elaborate formula that combines these two to give you the pooled variance, but I think that's beyond the scope of this course. So really, this is what I wanted you to deal with. Now this hypothesized mean, this is really important. This is the null hypothesis here, 0. What does that mean, the null hypothesis of 0? Well, what we're actually doing here is we're testing the difference between older movie lengths and newer movie lengths. So this null hypothesis here says there is no difference, that newer movies on average have exactly the same length as older movies. And that's what we're going to either reject or fail to reject. Remember that we never accept the null hypothesis. So we get our t statistic here. What this means is that the mean of the older movies was negative 2.65 standard errors in relation to the newer ones. In other words, it was 2.65 standard errors below the newer movie lengths. Now, standard errors, what is a standard error? Well, we'll get to that in just a second. But for now, know that that's what that meant. One-tail or two-tail test. Because we're not specifying going into this test which type of movie we think is longer, we have to do a two-tail test. And in general, this is what we're going to do, is a two-tail test. Only on rare exceptions will you do the one-tail. And we get a 0.009. So what that tells us is that's less than the alpha of 0.05. It tells us we are going to reject the null. So the decision here for this test is to reject the null. Now, some of you pointed out that you weren't real happy with how this sample was taken or things like that. Those are all legitimate concerns that would go in the overall critique of the study. But in terms of interpreting this data and whether or not to reject the null, that's all based numerically on whether or not this p-value is less than the alpha value, and it is, so we reject. We could also look at if the absolute value of this is higher than the t-crit, critical t-tail, which it is. This is telling us basically we need to be at least 1.98 standard errors away from each other to reject, and indeed we were 2.65 standard errors away. And again, I'm talking about the average movie length time of the two sets of movies. So we get our pooled standard deviation, which is just the square root of the pooled variance. The effect size is the difference in movie times, so 18 minutes divided by this F15, the pooled standard deviation. And this is a medium effect, by the way. And then the standard error, we take the pooled standard deviation times the square root of 2 and then divide that by the square root of 50. So this standard error is what we're referring to with all these t values. So when we say that the older movies are 2.65 standard errors below the newer movies, we're saying 2.65 of these 6.85s. In other words, we would multiply this number by this number, and that's how many minutes lower we are. Okay, so the standard error is 6.85 minutes, and we have 2.65 of those standard errors below, and we really only needed to be 1.98 of those standard errors below. This one needed to be that many standard errors below or above this one in order to get a significant test result, which we did. The main lingering confusion here is on these two numbers. So first of all, make sure you have the order right. It should be the difference between the two movie lengths minus your t critical over here times your standard error. And that'll give you 4 and 31 for your 95% confidence interval. But what does that actually mean? Well, it means that we're not talking about overall movie lengths here. We're talking about the difference in movie lengths between the older movies and the newer movies. So we think that the real difference in our sample was 18 minutes, right? But we know that that's just a sample, and we want to know about all movies. So what we're saying is, based on these data, the real difference between old movies and new movies is somewhere between 4 and 31 minutes, favoring the newer movies. In other words, newer movies are between 4 and 31 minutes on average longer than the older ones. We're 95% confident in that. Now, of course, all of this is based on a good methodology where these movies are sampled randomly, which they clearly were not for this study. So that's where there's some critique, some room for criticism there. But in terms of the actual analysis of the data that we got from this sample, we can say that we're 95% confident that newer movies are between 4 and 31 minutes longer than older movies on average. So it's not talking about total movie length time, it's talking about difference between older and newer. Notice also that 0 is not within this range, right? This range is between 4 and 31. So why would I care whether or not 0 is within that range? Well, remember that our null hypothesis was 0, that there is no difference between older and newer movies. Well, I'm 95% confident that 0 is not within that range, right? 0 is not between 4 and 31, which also tells me that I should reject the null. So we now have 3 different ways, 3 different signals towards rejecting the null, and those 3 signals should always add up. The null hypothesis, whether or not it's inside the confidence interval, the p-value, whether or not it's less than the alpha, and the absolute value of the t-statistic, whether that's greater than the critical value. All 3 of those should lead you to the same decision, which in this case is to reject the null and say that, yeah, we have some evidence that newer movies are older. Newer movies are longer than older movies. It's been a long night. All right, please let me know if you have any questions on that.